Hello Gators, this is 1.5 determining limits using algebraic properties of limits, using algebraic manipulation, and selecting procedures for determining limits. Let's take a look at the properties of limits. So if we have two limits that we know, then we can do the sum rule. The limit of the sum is the sum of the limits. The difference rule, the limit of the difference is the difference of the limits. Let's take a look at this particular problem and see what we can do. So we want to find the limit of this expression, and we know all of these limits right here. So let's go ahead, and we know the limit of the sum is the sum of the limits. So I have this sum and I have two limits instead of one now. I'm going to let one go in here. As I approach one, I'm approaching f of negative 1. So I'm getting close to f of negative 1. And then over here, as I get close to 1, I'm getting close to g of 1 over 2. F of, as I approach negative 1, f of negative 1 is right here. I'm approaching negative 1, and that answer is 2. Approaching g here, approaching 1 of g of x, and that'll be 6 over 2. So that's 2 plus 3, which is equal to 5. There are more limits, a product rule, a constant multiple rule. If you have a constant in here, then you can move it out of the limit process and just say k times the limit of the function. The quotient rule limit and the power rule limit. All right, let's go ahead and find this limit right here. This looks awfully complicated, but I want you to understand that this part is the limit right here. This is not. This is just finding the value of the function, which we taught you back in Algebra 1. So let's take a look at this. So this is the limit process right here. And as we get close to 5, h of 5 will be the limit. As we approach 5 is 5. That's what I put here. F of x will approach 6. G of x will approach negative 1 here. All of these are the values for all of these functions. That's going to be 5 times 4. This is just the value of the function, which is over here. So this is minus 3, and so the answer is 17. Now let's take a look at the rule for the limits of composite functions. So as long as the limit exists and f of x is continuous at this k value, then we can just find the limit of, we're going to find f of the limit of the inner function. So I'm going to find f of the limit of the inner function. And so I'm going to get close to 4. And as I get close to 4, it looks like the y value I'm getting close to. So this whole thing is getting close to the number 1. So now f of 1, and if I look at the graph f and f of 1 is negative 1. So here, as we get close to 1, the y value is negative 1. Now let's take a look at a little more complicated one. We're going to again look at the limit of the inner function, which is 5. As we get close to 5, we're getting close to the number 0. And then we want to find f of 0. And f of 0 is, we can't find it. So we're not going to give up. What we're going to do is we're going to use the definition of this limit and find the right side and the left side. Okay, so I'm going to examine x as it approaches 5 from the right-hand side, and I'm going to examine this. This is going to be getting close to 5 from the right-hand side, so 5 from the right-hand side right here. It looks like this is going to be getting closer and closer to 0 from the right-hand side. In other words, these y values were positive, 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 positive when I got closer. So I was really, I'm really looking as x approaches 0 from the right-hand side as I examine f of x. So all of this is getting closer to 0 from the right-hand side. So now I'm going to go over here to the right-hand side of 0, and it looks like f approaches the number 2. So this is the number 2. Okay, now I'm going to do it on the left-hand side, and I'm going to change my color. So now I am approaching from the left-hand side, and this whole thing right here, the left-hand side, is getting closer to 0 as well. So this is getting close to the limit as x approaches 0 from the right-hand side, because these y values are getting smaller and smaller from the right-hand side. F of x, and that answer is, now I'm going to go over here and I'm going to approach 0 from the right-hand side, that is 2. Since the right-hand side of the limit is 2, the left side of the limit is 2, the answer is 2. So you need to be careful with graphs and make sure you do left side and right side as you examine them. All right, let's take a look at piecewise functions, and we're going to be looking at left and right as well. So I'm examining -5 from the left, and remember this is -5, and when we are less than -5, that is the left, and when we're greater than -5, that will be the right. So that's viewed as positive, that's viewed as minus. So we're going here from the left. So that means we're going to use this as our function. We're going to put -5 in there. So that'll be the square root of 16, which is 4. Now let's examine approaching -5 from the right-hand side, which means we're going to be using this. So that will be -2 in the numerator. And in the denominator, when I put -5 in here, that'll be positive 25. 5 take away would be -20, and so the answer would be 1/10. Over here, as x approaches -5, remember this, the left side and the right side have to be same. Clearly they are not the same, so this is a does not exist. All right, let's take a look at this one. And we are going to look at -1, so which means we have to look at both the left side and the right side. Okay, so the limit as x approaches -1 from the left side of g of x will be equal to, put a -1 in there, that'll be square root of 9, which is 3. Let's take a look at the limit as x approaches -1 from the right side, right over here. So that'll be g of x, that'll be 26 minus 5 all over 7. And clearly, let's see, that'll be 21 over 7, which is 3. So those look like the same values. So we do have a limit here. Now let's take a look at approaching this limit from the right-hand side. So remember our number line, -1, e, we want to approach it from the right-hand side. So that means we want to use this right here. So this will be the natural log of e to the 3rd power, which is equal to 3. That would be the simplified version. Now let's take a look at approaching e, and we're going to have to approach e from the right hand and the left hand. We know what the right hand looks like. Let's examine the left hand and see if it's the same as x approaches e from the left side. And this is going to be 26 minus 5x squared over 7. And we're going to have 27 minus 5e squared over 7. And clearly that will not be equal to 3. So this is another does not exist. All right, there are different strategies to finding limits. One of them is direct substitution. And we always try that one first, and if it doesn't work, then we try other strategies. So this one would be a 1 minus 2 minus 4, so the answer is -5. As x approaches 2, there's nothing to substitute. The answer will always want to be equal to 6. Now here, if I substituted, I would get 0 over 0, which is indeterminate form, which means you got to try another strategy. And the strategy to try is to try to factor. So I'm going to take the limit as x approaches 0, and I'm going to factor an x. So this is 4x minus 5 all over x. And now I'm going to reduce. And this right here is this graph right here. And Well, this whole thing here is the graph because there's a hole in it, and here's the hole where that red dot is. But when I reduce this, I only have the straight line. So in the end, I no longer have a hole in the graph. Actually, this is a nice straight line. And when that happens, it's easy for us to go back to substitution. And so we just put 0 back in here, and the answer is -5, which we clearly see in the graph that we're getting closer and closer to the number -5. This is also another problem where we can use factoring. First, determine when you substitute, you get 0 over 0, and we can do some factoring in the numerator, and then we can reduce. So now we have a function that does not have a hole in it, which will allow us to use direct substitution, and the answer will be -1. Here's an example. When we do substitution, we can see clearly that we are not going to get a good result. We'll get a value in the numerator, but not a value in the denominator. And so we have a does not exist. Let's take a look at other algebra techniques that will allow us to find a limit where normally we may not be able to find one. So let me go ahead and substitute, see what I can do. This is going to be a 5 in here. That'll be 3 minus 3, which is 0. Put a 5 in here, that's 0. This is an indeterminate form. Don't give up on it. And what we're going to use is what we call rationalizing. So I am going to multiply by the conjugate. So this is root x plus 4 plus 3 all over root x plus 4 plus 3. All right, and now I'm going to take the limit and I'm going to simplify. And when I multiply through, I am going to get x plus 4, and then this will be minus 9. And then down here will be x minus 5 times root x plus 4 plus 3. Now the good news is that this simplifies to x minus 5. That's what this whole thing simplifies to, which means I can do some reducing, and that'll be a 1. And now I can use substitution and put 6 into here, 5 into here, and that'll be a 6. Okay, stop the screencast and see if you can try this one. And here's the answer. I'm showing all the steps on all the algebra that's necessary to get it. Here's another technique, algebraic technique, and this is where I need to get simplify these fractions. So I'm going to get a common denominator, and that common denominator will be 4 times x minus 4, which means my new numerator here will be 4 plus x minus 4. So now I have a complex fraction, which I had one to begin with, and now I still have another one. And so this will be an x over 4 times x minus 4. Okay, now what I'm going to do is I'm going to multiply the numerator and denominator by 4 times x minus 4 and 4 times x minus 4. What I'm trying to do is make the denominator look nice. And so now I have the limit as x approaches 0 of x times 4 times x minus 4 all over x. And I can do some reducing, some cancellation technique, and then I can substitute, and then the answer is -16. Stop the screencast and see if you can get a common denominator and do much the same algebra process. And here is the answer. Got a common denominator, and then went ahead and made sure I got rid of my complex fraction, and then got an answer.